Okay, so in this video, we are going to wrap up our discussion on surface area by doing some more examples on composite solids, which can be the trickiest part with surface area. So in order to knock this out with composite solids, we need to recall all the different surface area formulas that we've been dealing with. So surface area of a prism or a cylinder, that has two bases, so it's going to be 2 times the area of the base, plus the perimeter of the base times the height. Surface area of a pyramid or a cone, that has one base, and then we need to do perimeter of the base times the slant height divided by 2. And then surface area of a hemisphere, remember that is the dome plus the disk to give us 3 pi r squared. So those formulas are going to be very helpful when we're dealing with composite solids. So in example 1, in this first one, we have 2 different figures here. We have a cone and we have a cylinder. So for the cone, that area formula is area of the base plus the perimeter of the base times the slant height divided by 2. Now we think about what part can we not touch. For the cone, we cannot touch the base of the cone because it's fused together with the cylinder. So I'm going to cut that out because we don't need to find the area of the base because we can't touch it. Okay. For a cylinder, we have 2 times the area of the base plus the perimeter of the base times the height. For the cylinder, we cannot touch one of the bases. We can touch the far right base, but we cannot touch the second base because that's where it's fused with the cone. Okay? So now we are going to work through this and find each part and then add them together. So for the cone, perimeter of the base, the radius is 2. So the circumference is going to be 4 pi. Slant height is given to us. That's 7. Okay. Now to find the part for the cone that we can touch, we've got perimeter of the base, 4 pi, times the slant height, which is 7, divided by 2. When I simplify this, that is going to give me 14 pi. Okay. For the cylinder, area of the base, pi r squared, which is 4 pi. Perimeter of the base is 4 pi, and the height of the cylinder is 5. So when I set this up, I get 4 pi plus perimeter of the base, 4 pi times the height, 5. That's going to give me 24 pi. So to find the composite of this figure, or the area of this composite figure, sorry, I'm going to take 14 pi plus 24 pi. So the surface area is going to be 38 pi inches squared, or that's going to be 119.381 inches squared. So that's for that first one. For part B, well, on top, we have part of a cylinder. Specifically, what's happening to it? It's a half cylinder. It's being cut in half. So that's a half cylinder on top. And the bottom part is a cube. So we need to find the surface area of half a cylinder. So surface area formula for a full cylinder, 2 times the area of the base plus the perimeter of the base times the height. But what's new is I need to cut that in half. For the cube, that is 2 times the area of the base plus the perimeter of the base times the height. But we can't touch the top base. So we are going to forego multiplying it by 2. Okay? So now we need to work through to find half cylinder and the cube, and then we're just going to add them together. So for the half cylinder, the area of the base, the radius is 2. So the area of the base is 4 pi. Perimeter of the base is 2 pi r, which is going to be 4 pi. And the height of that cylinder is 4. So if I plug this in to find surface area, 2 times the area of the base, which is 4 pi, plus perimeter of the base, which is 4 pi, times height, which is 4, divided by 2. That's going to give me 12 pi. Okay, so that's the half cylinder. For the cube, area of the base, that's going to be 4 times 4, which is 16. Perimeter of the base is also going to be 16. And the height of this cube is 4. So surface area there is going to be area of the base, which is 16, plus perimeter of the base, 16 times height 4. And that is going to give me 80. So for the composite, all I need to do is take the half cylinder, 12 pi, plus the cube, which was 80. And so that would be the exact 12 pi plus 80. The approximate is going to be 117.699 inches squared. So that is that one. Now we get to our honors challenge problem. Find the surface area of the composite solid. And you'll notice that a cylinder has been cut out of the middle of this cube. So there's several things that make up this, because you have to think about what you can touch. In the cube, so that formula is 2 times the area of the base plus the perimeter of the base times the height. Okay? So that is the cube. But we can't touch 2 circles because those have been cut out from the sides of the cube. So we are going to need to subtract the 2 circles. And then what happens when we remove those 2 circles is that we can now reach in our cube and touch the sides of that cylinder. So we can also now touch part of a cylinder. So I want you to try to visualize that and think about it. What can you touch? For the cube, we can touch all the sides, except on 2 of the sides, there's a circle cut out. And when those circles are cut out, we can now reach within this 3-dimensional figure and touch the side of the cylinder. Okay? So for the cube, area of the base, you'll see that those side lengths are 5. So the area of the base, 5 times 5 is going to give me 25. Perimeter of the base is 4 times 5, or 5 plus 5 plus 5 plus 5, which is 20. And the height of this figure is also going to be 5. So for the cube, we have 2 times the area of the base plus the perimeter of the base times the height. But we need to subtract the 2 circles. So we need to subtract 2 times pi r squared. And the radius of those circles is 2. Okay, so after simplifying this, we are going to get 150 minus 8 pi. And that's going to represent the cube with the 2 circles removed. Now we need to think about the cylinder. Surface area formula for a cylinder is 2 times the area of the base plus the perimeter of the base times the height. But if I think about this, I cannot touch any of the bases of the cylinder because the circles have been removed. But I can go within that cube and touch the lateral surface area, or if you want to think about it like the sides of the cylinder, that thing that wraps around the 2 bases. So perimeter of the base, circumference of a circle, 2 pi r. So this is going to be 4 pi. And the height of the cylinder going from circle to circle is going to be 5. So the surface area of the part of the circle that I want is going to be 4 pi times 5, which is 20 pi. So for the composite, we're going to take the cube part, which was 150 minus 8 pi. But now we need to add 20 pi. We need to add the part of the cylinder that we can go within the cube and touch. So that is going to give me an exact answer of 150 plus 12 pi inches squared, or an approximate answer of 187.699 units squared. Oops, sorry, this is not inches. Units. Units squared. Okay? So that is a tricky problem. Trickiest part with composite solids is thinking about what are the surfaces that you can touch. Okay? Think about what you can touch. Try to visualize it as best as you can. If you have any questions, let me know. I'm here to help. Other than that, you can continue working on problem sets. That's going to wrap up surface area. The next two targets deal with volume. So that'll be in the next couple of videos. Have a good one. Be safe, be good, do good. I'll see you when I see you.